Hi, folks. I think we're going to go ahead and get started. Welcome to the session on drafting policy frameworks for cloud environments. Or really, we're just going to talk about the entire concept of policy-based networking or intent-based networking in general, in or out of the cloud. My name is Craig Matsumoto. I am managing editor with SDX Central. Been writing about SDN and networking and all this new open source stuff that's been happening. And as part of that, this whole idea of policy-based networking has kind of crossed my path. It's really interesting, and we've got some really great panelists to talk about this a bit. I'll let them introduce themselves. Why don't we just start with you, Tim? I'd like you to just say who you are and where you're working, and in your case, what you're doing.
Very funny, Craig. Yeah. All right, so my name's Tim Hinrichs. I am working at a startup called Styra. It's about 2 months old. Very exciting stuff, I'll tell you, but that's all I'll tell you. I'm also the technical lead of the Congress Project in OpenStack, which is doing policy for the data center. Really, I've been doing policy pretty much continuously for about 14 years. And a number of years ago, I did get my PhD from Stanford in declarative languages, so basically policy languages.
Tim, where were you before Styra?
VMware.
Hi, I'm Mahesh Venkat. I'm a distinguished technologist at HP. Recently, I've been working in this ODL and policies and NIC and intent area for past about few months, about half a year. But before that, I've been leading a lot of cloud projects at various companies, including Intuit and eBay. So it's a pleasure for me to start working in this side.
My name's Keith Burns. For those of you who are hoping to see someone credible like Mike Dvorkin, sorry for the bait and switch. I work on the Groupbased policy project in OpenDaylight on the PTL, employed by Cisco. Before that, I was an equity trader, and before that was in networking for about 20 years. So that's kind of my background, going to software development by a very weird route. And yeah, GBP is my policy angle.
Okay, great. And our fourth panelist is Mathieu Lemay with InnoCybe, or it's probably really pronounced InnoCybe or something because he's from French Canada. Mathieu will probably be joining us during the presentation, so since he's not here, you can make up your own story about him. Anything you think, it must be true.
Mathieu owes me $500.
There we go. So why don't we start with the basics. I'm going to open it up for questions from you all, and I'm sure some of you are very well versed in this whole policy intent idea, but just to sort of make sure we're all on the same page, why don't we start by talking about what do we mean by policy and intent? Policy is a word that's been around the network for a very long time, right? So Tim, I'm going to pick on you to start. What are we really talking about here?
Right, so I think this is a good place to start because everybody who says policy probably means something different, right? So in networking, we care about policy about network traffic. If we go and talk to somebody in the application world, maybe Kubernetes and the like, they're talking about policy over where they want to place containers. If we talk about to somebody from the storage arena, they'll give us a different answer. And I think the question is, who's right? And my answer is, well, everybody's right, because everybody has some common idea that is shared, and that idea is pretty simple. Like, what policy and intent means to at least me, and we'll see what everybody else thinks, is that it is this separation between the desired state of the system and the actual state of the system, right? What you want, not how you get there. And once you're in this world where you've actually separated those two things out, then you're starting to talk about policy. Then you're starting to work in the world of intent, right?
Yeah, from my perspective, policies are applied at different levels based on the actors. For instance, you got the enterprise admin, you got the application admin, you got the SDN app admins, and you got the cloud administrators. And when you have so many actors coming into play, at the same time when you have multiple tenants and also the type of data packets that you want to manage, right? That's where you want to define intent at a higher level than what you're defining at a low-level ACL. So essentially coming to what you're saying is intent is what you want to do rather than how you want to do, and translating it in a very automatic way to be enforced.
Mm-hmm. So Keith, I'm going to, you can contribute as well, but I'm going to ask you to take it a step further. Why do we care? So we have this concept of being able to describe things at a higher level. Why does that matter? Keith. We'll give Keith a chance to talk.
Yeah, let's give Keith a chance. Which is great you changed the question, because after following both those descriptions, I was sitting there going, and what they said. Why do we care? So Tim hit upon part of this quite eloquently, and the words what and how come up all the time. And people say it's the difference between what and how. Intent systems and policy systems is all about what, not the how. But there was an acknowledgement there, but it's more about the desired state. Getting to the how, you don't want to specify the concrete and granular hows, because it'll get to the why when you can specify the whats. Because as it turns out, part of it, and this is a personal belief, is that infrastructure is inherently best effort, despite all our arm waving and things of this nature. Infrastructure is inherently best effort, and when you embrace that, you begin to see that when you start to put into a series of steps of how, it's inherently fragile. And when these things break, they're problematic to fix. And if instead you can say, this is what I want, go and sort it out, but there's an acknowledgement that there has to be a how. There has to be that translation into making real networking happen. Because at the end of the day, you're just expressing a pretty API and a pretty orchestration system. You really need to close that loop in order to be able to say it is a full feedback loop. And we'll perhaps get onto that in a bit more detail later on if we get the chance. But there's all those components there. It's not what versus how. It's how you interact with the system to get to how. Is that fair, do you think?
Sounds good. Matthew, any more thoughts on why we care about this?
Yeah.
It did have a quick follow-up after we let Matthew actually say something. We'll prove that you were here.
Sorry about that. I was in another
that's
talk
okay.
and
Yeah.
had to come over. But yeah, absolutely. I think Keith nailed it in the fact that it's the first step towards actually bringing intelligence to networking. In order to have an intelligent behavior on top of any networking fabric, you need to know what is intended, what you're actually trying to achieve. If you don't have that knowledge, it's very hard to make good algorithms and good predictive analysis about the system and the state and the desired state, right? So making good conflict resolution or any other changes within the infrastructure, you need to know the context of the request. What was the user trying to achieve from a user perspective, and not simply from a technology or API perspective.
Okay, so the contrast is basically you're no longer dictating to every single network element exactly what it's supposed to do. You're telling it what you meant, as opposed to what you're exactly saying. Now, Keith, you had mentioned something. I wanted to get into that feedback loop idea a little bit more, because you had mentioned the succession of hows, telling each box how to do things, and then if something breaks, things go wrong. What can you elaborate a little bit more on what you meant by that? What is it that typically breaks, and how does policy fix that? Because won't that thing still break?
Yeah, but things will break, and that's part of the feedback loop. And that's one of the gaps in the implementation of group-based policy as to what we set out and have said we will do, and where we are in Lithium and tend to work on in Beryllium, and that's instrumentation or governance, right? So when you convert, say, an expressed intent in terms of a declarative type, this is what I want, and you convert that into a real network semantic, which is a how, right? You have to tell the network how to do things, regardless of, what it is you express up here. Network elements only understand how. Alongside that, you also want to impose some operational constraints, so that you can still have some form of control over what people can and can't do, but you give them the freedom to express what it is they want. But that other part is the governance, right? This instrumentation. Okay. And more importantly, and we can throw statistics around all we want in terms of data from network elements, it's not so much increasing instrumentation, it's about removing opacity, right? It's about, because when we start declaring things in terms of contracts and policies, right, it can seem like a bit of a black box. And you have to get away from that. You have to give people the information and the data about what's really going on under the covers, without just dumping a whole lot of port counters or flow counters or network element interface counters and saying, you work it out for yourself what's going on. You can say this contract in between these two subnets is doing this, regardless of the number of network elements involved, that kind of thing.
It's still a little bit of a black box. It's a blacker box. Not a horrible phrase, but it's a blacker box than before, right? Because you don't need to know all the mechanics of what's happening. You know what you told the network you wanted, and the network tells you whether it happened or not. right? You get that information, but there's a lot in between that you no longer have to mess with under.
Should I respond or? I don't
Oh,
want
yeah.
to all the time.
That's
It's not the absence of network element instrumentation, right? It's more representing it. If you say this is what I want, you want some confidence that what you asked for is actually delivered. So the instrumentation needs to be up-leveled, right? So you don't need, so if you just simply dump, I'm not saying you never ever dump port counters and things like that. If you want to drill into that level, you need to be able to pull it out and extract what the network's doing. For instance, we use OpenFlow renderer today. We may have a BGP one or a list one in the future, but for now it's OpenFlow. So the example would be, can you see the flow mods that actually are going through the switch that represent this policy between two endpoints, or for that matter, two endpoint groups, or endpoint groups on particular subnets, right? In our example, right? You may have a contract in between web and client is the typical canard, but the endpoints may exist in between San Francisco and New York and Paris and Tokyo. So simply saying what's the instrumentation for that contract is not sufficient, because what does that really mean? But you don't necessarily want to get to the granularity of the endpoint, because the user doesn't care. They just want to make sure that traffic going between my groups of things that I care about, web services, between, say, these two subnets, because that's a pretty logical breakdown, is performing at this level. You also want to be able to say that, you know, I care about this contract more than I care about this contract. I care about my contract to the financial database more than I care about my contract to the internet. That's what I mean by the feedback loop of instrumentation. It doesn't obviate the need for network element-based instrumentation at all.
Okay.
It's a up-leveling and supplement to that.
Okay. So
Does that help answer the question?
it does help answer it. Yeah. Well, yeah. Something else I'd kind of like to specify though. When we're using the network in this way, when we've got this policy-based infrastructure set up, who am I, the user or operator, talking to? Am I talking to some translation layer that then talks to the actual network elements? Or is the answer it varies?
I'll finish here because I started down this path and you asked me a question. Now I really should cede time to my co-panelists, right?
Okay.
So the entity interacting with it, we've got to get away from this idea that it's people interacting with it. It doesn't have to be. Case in point, we did a mapping of Neutron. I think we come down to domain-specific languages, and it comes down to another belief that core policy models should be non-domain specific, right? You should be able to provide hooks for the domain specifics to get stuff done, the how that Tim pointed out. But the core model itself, the resolution process, should be non-domain specific. It should be applicable to CPU. It should be applicable to storage at its core.
Okay.
And then you can map domain specifics to it.
Well, it doesn't have to be a person. What I was trying to get at is drilling down into a bit more of the how or what comes next now that we have this concept. To set that up a little bit more, why don't we talk a little bit about what is being done? Because there's a group-based policy effort in OpenDaylight, and I think there's one in OpenStack as well. And then there's something called Congress. What is the difference between these, and why do they all exist? And what state are they in? Like how far along are they? Tim, do you want to talk about that?
So I'll say something, and then Keith and everybody else can complain. So from my point of view, OpenStack Congress and the efforts, at least in OpenStack, which in that case GBP is situated in the networking component Neutron, right? They're actually complementary technologies, right? So Congress is this policy engine that's designed to be completely domain agnostic, and I'll get back to Keith's comment in a minute, meaning that you can write any policy over any domain that you want, and you can write policy about, which means you can write policy about compute. You can write policy about networking, you can write policy about storage, about the antivirus, about some proprietary service that only the customer at the deployment site actually has. You can write policy about how all those things interact, you can write policy about applications, right? There's nothing in terms of the domain that's built into Congress, and this is its selling point, that you can actually express whatever policy that you want within Congress. And at least in the OpenStack world, the way we see that being complementary to GBP, which is a networking, situated in the networking component there, is that GBP is specialized to handle networking policy. It's great at enforcing networking policy. Why? Because it knows it's been given a networking policy. It knows that fundamentally the policy it's given is talking about network traffic. And so it's incredibly great at enforcing networking policy. Congress is great at expressing any policy, and in an ideal world, what we keep talking about doing is taking a Congress policy, pulling out the networking piece of it, and handing it to the GBP engine inside of Neutron. Letting it do the enforcement, letting GBP do the networking enforcement. Why? Because it's custom built to do that. It's great at doing that. All
Yeah, from my point of view, what GPP is providing you is defining these policies that you can enforce, at a specific set of ACLs for a given set of what you call the standard ACL models, right? But it is more applicable more at the network layer. But if you want to define policies across compute engines and different type of domains and across different type of enterprise admins versus the cloud admins and others one, then you need a higher level policies or a policy from where you can derive the low level ACLs, right? In some form of a modeling, and we don't have it there, right? But there are some projects going on where you can do high-level modeling of combination of tenants versus the service chains, as well as the whatever the network-level policies that you want to provide, and together you can create a composition across that and drive down to different layers. So that's, but those projects are still in very incubation stage, right?
Okay. Okay, Matthew, did you want to?
Well, basically, I don't know if it's been said already, but it's always, I'll take Keith's and David's. Someone's abstract is another one's concrete, or actually you can phrase it however you want. But that's fairly true. In other words, there's always another layer of abstraction and like on top of you, depending on what you're trying to do and build.
Okay, so what state or the Congress and the group-based policy projects in? Are they done? Are they ready to get used?
Yes. No.
Yes, no.
Is any project ever done?
That's true. No project is ever done.
I think that's partly answered, but no. So Congress was officially adopted as part of OpenStack a few months ago, maybe 6 months ago by now. So that was a big milestone for us and in the OpenStack world. It's recently become less of a milestone because they adopted a different governance model where it's relatively easier to get projects in. But nevertheless, a milestone for us. We're very excited by it. And so in terms of maturity, we have definitely a roadmap ahead of us where there's a bunch of things to do. But in terms of basic functionality, can you use Congress can you ask Congress questions like, if I were to execute this action, would that cause any new policy violations? Yeah, that's there, that's ready. So you can use that kind of thing. Can you write policies that say, under these conditions, execute some actions, such as, every time you see a network VM connected to the internet that has port 80 open, go ahead and shut that port 80 off. Yes, you can do that too. There's a long road ahead, and what we don't have yet today is really this functionality that I talked about a moment ago, where you do work, the user gives Congress some policy about every domain under the sun, and then Congress pulls out the networking piece and hands it off to GBP. Like, that doesn't exist yet. Okay. We're working on it. We've done the first, initial prototypes of that kind of functionality, but it's certainly not done yet.
Mm-hmm. Okay. By the way, my line of sight keeps getting drawn naturally this way for these guys, but I don't want to ignore you folks in the audience. This is a complex topic with a lot of different points of entry. So if you have questions, don't be shy. Just wave and holler or throw something at me. So what do we have to do in the network to make any of this happen? So we've got these great ideas. We've got this policy concept. We've got Congress and group-based policy getting formulated. What does it mean to implement any of this? How much of the network has to change? Like, how radical of a step are we talking about?
None. So, Open vSwitch and OpenFlows existed for a long time.
Okay.
We didn't have to change anything with Open vSwitch and OpenFlow to make this work. The key thing is you map either the REST API or declarative language into policy constructs, whether that be mapping Neutron as a DSL into the policy constructs, or whether it's directly the expression of a contract via REST into policy constructs. Then you resolve policy. The core policy model has 2 domain specifics that are mistakes, and I would have ripped them out in Lithium, and they're one-line mistakes, but we have to do backwards compatibility and deprecate them. We've already put them in the endpoint where they belong, and that's it. So otherwise, there are no domain specifics within the core model. They're injected via the renderer. And that's the real work that happens. The renderers have to understand the policy model and turn that into concrete things on the network. For instance, as I mentioned, we do Open vSwitch. We say it's the OpenFlow overlay renderer, but we use Nicira registers that extensively. It's an OVS implementation. If you did BGP, if you did Lisp, if you did REST, and I'd love to say that RESTconf was this all wonderful, singing, all dancing interface, but there's that many proprietary hooks. I can't just say I'm going to do a RESTconf renderer. You're going to end up having some hardware-specific things in the model. It's just the reality of the situation. The point is, the network does not have to change. And I would contend that policy, just like Tim said earlier, policy has existed for so long. This is not a new thing. And there's been many attempts, successful and less successful, to programmatically do it. ITIL's been around a long time. Policy has existed.
Right.
But we're trying to do it in a programmatic fashion, right, without having to change the network elements themselves. Right? It's the automation of intent, not the revolution of the entire network.
Okay, you see it the same way, Mahesh? Just double checking. Yeah, plain. Yeah.
I was just going to ask, so if it's been around for so long, can you speak to why it hasn't succeeded up to this point? I mean, maybe that's a good question.
Go, man, go.
Yeah, if I want to say, converting a very high-level intent into low-level intents or low-level orthogonal intents or the ACLs, it's a tough call. It's a complicated problem to solve. In the sense is you want to say not just converting into a X number of low-level orthogonal ones, but you also need to handle any conflict resolutions. And not all of them are automated. For some cases, you have to raise it up to the administrator or the user. And also you want to give a right level of prioritization and precedence values if you want to give when there are conflicts or when there is when you want to compose a bunch of interns in what order. So it's not a very easy problem to solve. And now I think more and more we are attempting to solve that problem, right?
I wouldn't disagree, but my perspective is, from what we've done in the 2 releases that we've been involved in, having explained this quite a bit, but obviously not doing, well, you can explain these things as much as you want, but it comes down to instrumentation and removing the opacity, right? I just invented a thing called Fugal sort. Right? Fugal sort. It's a wonderful thing. It's order inverse n. That means the more data you throw at it, the faster it sorts. It's amazing. I threw it at a Hadoop cluster. I invented time travel. It's amazing stuff. And the really cool thing about Fugal sort, well, how's it work? Well, what we do is we take your data and we put it into groups. And in between these groups, we have contracts with classifiers, right? With subjects and actions. It's fantastic. You're going to love it. And here's the cool thing. There's no domain specifics. You have these thing called renderers, and you plug it in. You're going, I still don't get it, and I don't trust you. Fine, but if I actually was able to show you the quick sort, not Fugal sort, because quick Fugal sort is proprietary, and I'm saving that for venture capitalists, right? So, but if I could show you bubble sort, and you go through the algorithm, you can see it step by step, and you get this comfort that when you call this quick sort algorithm, you know what it's doing. It actually is order log n for argument's sake, right? Which is really what you're trying to do is reduce the order big O operations of quick sorting algorithms. That's what we need to work on in Beryllium. That's what I'm committed to doing, is providing that instrumentation so you know what's going on. Not, yep, she's right, mate, all good. But you have that comfort level. You can dig into various levels of granularity that you need to do to feel comfortable. I think a lot of that is, we could work very well with Congress. It'd be great if you were an OpenDaylight project, man, because I love what you've done in OpenStack, to be perfectly frank. So, but yeah, that's really my focus for Beryllium.
I'll add to your statement. The fact that it hasn't been adopted is more of an operational than a technology problem. It's difficult to push these concepts out in the field because of what Keith was just saying. It's the confidence in the system, and like, do you trust the system to be more intelligent than the sysadmin or the person behind the network? And today, until the SDN revolution, or until the SDN NFV world, or change in the mentality, until cloud, in fact, cloud was the opening door for these concepts that existed for about 10 years. And now people are willing to at least give it a shot, understand more, and get involved at making the tools better, and especially getting the information and the metrics.
Okay. Yes, question?
So all this policy talk is getting hot and bothered. I come from Oracle, but in my previous life come from Cavian, which was a policy shop. We sold policy
Okay, so the question is about how all this policy stuff relates to the higher levels of the network. Basically, the application layer
Yeah.
kind of uses whether we're
Service initiation and service and marketing related, issues.
whether the people and functions who are way up there in the stack are going to be able to use this stuff, or does it become more of an engineering function? Are we getting a little bit too deep into the roots of the way we do this? And Mathieu, go ahead.
Keep looking at me. Like,
Yeah, no, I was just wondering if you wanted to add something. Actually, I think, yeah, I think it will simplify writing applications. I mean, there's two things. There's the policy part, and there's, let's call it the intent part. And with intent-based interfaces, it actually allows you to get more recursive constructs into how you can compose your requests from an application perspective. So when you are writing applications, it also changes SDN apps or any networking application that you would technically write to, just write down to OpenFlow, for example, or to a specific renderer. Then at least now you can write your application with confidence that it's going to be a little more portable, a little more usable across a variety of environments. So that's also another goal of intents. It is like leverage from policy, or policy is a little different from this perspective, but they complement each other.
And from my point of view, I've seen the ways to address your problems is the user provides, or the high-level user provides these policies as at the high-level input policies. But it is possible to translate it, which is what we have done in some of our prototypes. If you take the OpenStack horizon, where you got the policy sets, policy rules, so you can clearly define, you can populate it, auto-populate it from my input policy into composable policies and my deployable policies. So in that way, the end users of different levels can see how their high-level intents have been translated into the composable policies. And still, the end user has got a way to override the generated policies, right? And that's how you can see the translation going on. And that's one aspect. Second aspect is these composable policies or the deployable policies, the administrators or whoever the person who has specified it at a high level can test it even before deploying it. So those are some of the ways they can visualize how those high-level intents are getting translated into low-level orthogonal ACLs and policies.
Yeah, it's all good. So a couple of thoughts came to mind one is that I'm always worried about this. I'm always worried about who can actually use the system, right? I mean, I think, I've in Congress, I often give the talk and I say, well, this is all great. And then I show a snippet of policy and I sort of lose some people. It's quite clear, right? So that's something that you have to pay attention to, that policy languages are not things that we teach in school, right? We teach arithmetic. We don't teach logic. We don't teach policy. So it's certainly something to be concerned about. But at least in when I usually think this through in the Congress setting, which is this very rich language, part of the design was set up so that the policy writers could actually introduce abstractions themselves. So you start with some relatively low level inputs to the system, and then if the language is rich enough, you can imagine building up abstractions like is secure. Like imagine the networking administrator writes some policy and says, here's what is secure means for the network. The compute guy writes some policy and says, here's what is secure means for compute. Similarly for storage. And then you can expose that kind of higher level generality, that higher level abstraction to people who are higher up in the organization. Maybe the cloud guy can then say, here's what secure for the entire cloud means. And so what I actually see happening is this world in which you've got multiple different stakeholders writing different snippets of policy, just like we do sort of in a programming language, that gives those abstractions that the higher level people actually need in order to write the policies that they care about, right? Seemed like there was.
So it sounds like an abstractions on top of abstractions thing. Well, Mathieu was using that. No, I meant that. I know it sounds funny, but I meant that in a good way, where the higher up you are, the more you generalized you can make your command or your policy request in a way that filters down to these lower levels more specifically. Is that what you're talking about?
Or, that addresses what I wanted to say. I think, the more important part about policy, I feel, is that to achieve the central control. And, in my world, I call it capital P policy, right? The sort of stuff that SLA
When do the application people, when is our policy frameworks mature enough that the application people need to or can start working with them in mind?
I might ask a slightly different question, which is, what would motivate the application developer to learn like a new language, a new way of expressing the needs that their application has for the infrastructure? And I don't know the answer to this, of course, but so one of the things that might be easier than convincing the application developer that this is the right way to go is to convince an administrator, somebody whose job it is to keep the data center as a whole running well and efficiently and providing all the sort of capabilities that the application developers need. And the reason that could be easier is that if you think about what's happening in the cloud, what we see happening is that we're basically taking the administrator off the critical path for all the operations that change the data center, right? So in the old days before the cloud technology, it was the case that in order to get a new server or a new app deployed, you had to call somebody on the phone and say, hey, can you help me do this? And that guy had all these ideas in their head about real-world rules and regulations about how they had to deploy that app. With the cloud, that guy's been removed. He's been sort of replaced by software. You can spin up a new server, you can deploy an app without any human being in the loop. And so now there's this void, there's this gap. How does the software know what PCI compliance means? There are all kinds of organizational policies, federal, state, and local regulations about how that data center is supposed to behave, and so there's that void. So I can see it being much easier to convince an administrator to say, well, here's a tool. You can write down some policies that describe how the data center is supposed to behave, and rest assured that regardless what your end users are actually doing when they spin up servers, those rules and regulations will actually be obeyed, right? So give guardrails to the stuff that the end users are doing.
Right, and I would add, sorry, to.
When is that tool going to be mature?
I would say now, to answer your question, now. But here's the benefit, and there's a few, there's not caveats, but some common sense does apply. You've got to think about the constituents. You're saying, when will application developers embrace this? Or maybe I'm paraphrasing. It's not that they have to rewrite apps. We're not redefining new libraries in C and Java that replaces sockets and what have you. They can express that I want these two things, or I'm going to provide a service that provides port 80, right? I'm going to provide web services. I'm going to provide port 80 and port 443. Where it becomes interesting is you've got to think about the other constituents in this, which is the operator, right? So you've got developers and operators. And the operators want to be able to say, well, that's fine and good that you are going to say that your policy is that you provide port 443. But when you do that, or port 80 more to the point, if you do 443, I'm going to let you through. But if you do port 80, I need you to go through this service function chain, right, for validation. It's part of my operational constraint that I'm putting on the network. And so when you allow the developer to express policy, and you have the operational constraints, they can say, well, in that environment, I'm going to make you go through a service function chain. Then you have something actually very powerful, and we have that today. So I'd say you can consume it today. Right?
Okay, I think what he was asking,
But
I think more what he was asking was at what point is there something in policy that application developers can take advantage of?
Yeah.
When is there going to be something really cool they can do that they can't do now? Yeah.
Yeah, I can answer a little bit on your side. The day when we have a nice UI for modeling of these policies, right, in a very nicely, very user-friendly ways of defining these policies, is one aspect. Second aspect is the day when we settle down on our northbound intent APIs, which is portable across all the controllers, right? That's the time when the app people will feel comfortable to start leveraging this. And that is coming soon, because recently, as you can see, both in the ODL community as well as in ONOS, right, we have been striving to come up with a highly portable, composable, shardable intent API, northbound intent API, work across multiple communities. That is first step. Second step is very highly user interface for defining the modeling where the user can define their own tenants and their own services and draw down the dependencies. So those are the catalysts and enabling factors that will make it attractive for the SDN app developers to use it. And on top of that, the visibility that their intent is traceable down the network path So this gives the confidence to the end apps, hey, for a given policy that app is pushing to the controller, they are able to view it visible, both runtime. So these are some of the confidence building steps that will help the app developers.
Yeah, I'm going to have to agree with bits, but disagree vehemently with some bits. The instrumentation part, clearly, like Tim's hit upon before, is what I'm about to do going to violate something? Be able to have that assurance? Sure. And instrumentation, feeling comfortable with what you're doing. But transportability and mobility of policy across different controller platforms is a nice to have, but to me it's a third order problem. The ability to actually close that feedback loop is the key part. The ability to be able to compose these things with various levels of interdependency. Tim hit upon a key point before, the idea of being able to say, can I say is secure? Recently I've been doing some modeling with IoT, and when you start looking at this notion of different sensors out there, like a weights, this is a real tangible thing that we modeled, is this notion of, and I'll lead you down where this is going, you'll see, aha, that's a pretty cool thing. You've got a weight sensor, and you want it to register, say, over 1,000 kilograms. I don't know what that is in pounds, sorry. And you also want to measure so many megahertz in vibrations. So you've got two different sensors in there, your classifiers, and your action is then turn on camera. Now, when the camera then turns on, that's an action which then tells someone else to go and check the quality of service on the network, and is there enough bandwidth to carry the video. What are we doing? We're turning on videos at railway crossings, where cars go across. Why do you want to check the different weights? Because you want to tell the difference between a car and a train. The vibration matters. So now you can actually start to put these composable things together based on the raw sensors to some composable abstract thing, which becomes, the action becomes the classifier, and it's this composability. I try not to use the word hierarchical, because I don't want this to seem like it's structured, so I try and say interdependency, but that's the first order problem we have to get to, and this is why non-domain specifics are very key in core policy resolution. So that's a very tangible thing from IoT. It's about safety, right? And there's a whole series of things that have to happen in order for you to turn on the camera and say, aha, I'm going to capture this event. Now, I understand the intent. I think it's an admirable goal that we have mobile things, but to me it's a second or third order problem before we solve these other ones. So hopefully we can be cool with that.
No, punch each other, come on.
Actually,
A question in the front here. Sir,
yeah, it does depend on the use case, right? I mean, if it's really about resolving policy within an environment, I'm completely with you, Keith. However, I mean, if it's more from a simple SDN app portability type of thing, I mean, you have different angles based on what you qualify as SDN or what you actually view as a more of a programmable network environment, right? So different people view things differently on, well, for sure, but that was a useless statement. but no, honestly, it's really about, are you trying to write very focused SDN applications that you want to port across environments, or are you trying to solve problems or like complex use cases? And for me, that's been the differentiation between, for example, Nick and group-based policy in the deployments is Nick will be like a very simple interface that you can use to write the little app that does, okay, I want to inspect traffic. I want to do really very basic stuff without having to go to OpenFlow. Think of it as a smarter OpenFlow type of thing, right? So versus the group-based policy, which has the same capacity but is very powerful constructs and contracts that you can actually build to describe how you want things to behave, right? I mean, that's been the differentiation for me in the deployments.
Okay, all right.
So one thing, I was taking the piss out of Matt there, but we go way back, just so everyone knows. We're really good friends. Like, we call each other all the time and talk. So I was
Does he
making
know,
fun of him, but we do.
Does he know he owes you $500? That came up earlier. That came up while you were gone, Matthew. We had a question up front here. Okay. Yeah, something must sit between your high-level policy, your intent, and the actual network. Something must know what the network looks like. Who writes that? Who's in control of that? Mathieu, you've got a mic.
Yeah, well, I guess who writes that? I think it is part of your or your feedback loop. I mean, you can't really separate that from the rest.
But is it going to be something that the network, whoever provides you, the physical network is going to provide you? Is it going to be something that somebody at a higher layer provides, or does it just kind of exist? Where does this come from? Where does it live?
Well, right now, the intention or the intent is to have that as part of ODL. I mean, there's a lot of stuff within the beryllium cycle that's likely going to be on monitoring or knowing more about how you break things. So what to do when things break and the intent no longer is realized or the policy no longer is there. So how do you actually react to that? So it's going to be built in the system. If it fails, it has to notify you, and you need to know that you can no longer be processed or fulfilled.
Okay, so it would be part
Yeah.
of OpenDaylight. We're running short on.
The quick answer is, if you see some of the building blocks that we have both in GPB as well as in NIC, to translate from how to what, right? We got other components like the mapping service, okay, and renderers. So these are the components that are that's going to be cognizant of the network capability and the protocols. And there, you're going to build this translation between the virtual endpoint group definition to a physical group definition. And what are all the other protocols to support and populate those mapping database. And so there is a network operational aspect of how to populate those mapping service database to do the translation.
Okay, so a lot of this will live in OpenDaylight is basically what we're talking about. By the way, GBP, group-based policy, what does NIC stand for?
Network intent composition.
Okay, thank you. And final question, if you would. Difference between services and policies. Semantically, they could be the same thing, but
I'll give it a try. So I guess by service, you're talking about a piece of software running, or you mean something different?
I would guess the policies are the way that you make the services happen.
Service is a product, right?
Yeah,
It's
yeah.
something you consume. It has other things to it other than just orchestration, right? And policies are a part of that, constituent of that, I'd imagine, is how I quickly think in the short time. Tim?
Sure, yeah. I mean, maybe I'll answer a slightly different question, which is how is a policy related to a program? Is that in the ballpark? No, totally separate? Okay, then I just won't say it.
Did I answer?
Okay. Real quick, since we have just 1 minute, we talked a little bit about the policy language. Is there one policy language, and is that a non-domain specific kind of thing? I mean, do we know how we communicate policies? Tim, if I understood correctly, this had been a hot button of yours, that there isn't necessarily one language.
Right, no, I mean, so the nice thing about policy languages is that typically they're easily translatable. So if I can pick my favorite policy language, each of you can pick your favorite policy language, and then, we can translate between them, right? That's sort of one of the, fundamental things that you look at when you're designing a policy language is how does it translate to others. So I think in that sense, it doesn't really matter.
Okay.
I think maybe a separate orthogonal question is there utility in having domain-specific languages versus domain-agnostic languages? And I think I've spoken to that already to some extent. That
Sounds like
you need a little bit of both, or at least you need some domain-specific knowledge inside the renderer, if nothing else.
Okay.
And then what the language is used for in terms of expressing policy, well, that can be whatever.
Okay. Yeah, it sounds like in general we're trying to make as many things as domain agnostic as possible universally, though.
And there's an effort at the ONF, the Boulder Project, which is a new project launched by the ONF OSSSDN group in order to actually work on getting a common set of verbs and a common set of things from an intent perspective. So that's yeah, that's an initiative that I wanted to outline.
Yeah.
There's also a NEMO project, right? NEMO.
Yeah, there's also the NEMO DSL.
Yeah, there is also a NEMO DSL project in ODL, right?
Okay, so it's Nemo in ODL and Boulder in the ONF. All right. Great. I think that covers our time. Please join me in thanking our panelists. Thank you.